See that this is an aggregation of the same class. Like supervisor is a person which is aggregated from a class named person, so refer itself. And if we have like a group of supervisors as an array, we can do like aggregation symbols like that. One person can have many supervisors, right? One can have many supervisors. Now, we look at course class. Course class has course name, students, number of students. The constructor for course, for the course name, get course name, add student, drop student, get number of students. And this is the UML4 stack of integers. We have, so first what is stacked? Alright, so let's explain this, what is stacked. So if I have, it's like a bucket or a stack of a book, I'm going to draw a bucket, right? So if I push something to the stack, we say this is a push operations. Alright, if I push letter A into stack, letter B into stack. So this is called push. If I pop, so I can pop B out, which B is no longer in stack and A at the bottom. But if I push A first, I can't get A out. So this is called first in, first out, or first in, last out. First in, no longer first out, so it's going to be first in, last out, which is L instead of F. Right, it's first in is last out. Or sometimes you may hear say last in, first out. Phi, low, or LIFO. Right, last in, which is B, and first out. So this is called stack. Now we look at this as the data structure. Right, when we start a list of things into stack, we can pick what's at the beginning of the stack or the top. So this is the image of if I push data 1 in, data 1 in, data 2 in, data 3 in. I pop data 3 out, pop data 2 out, and pop data 1 out. So this is stack. So an example I draw here is stack of a letter. So this is stack of numbers, integers. So depending on how you create a stack, you can create it as storing the list of integers or the list of characters or string or even the object like student object, course object. So to implement the stack, we can use an array. You start pushing elements to index 0 or 1 until the size -1, which is that's the top. But array can have more. You can push more up to the limit of the size of array, which is capacity. We have a wrapper class. Now let's talk about wrapper class now. What's wrapper class? Wrapper class is the class that we use to create a class from primitive data type. Like we have primitive type boolean, we have class name boolean, which is caps B. We have type char, we have characters class. We have short, byte, integer, long, float, and double. Wrapper classes do not have no arguments constructors. So you have to pass the values to initialize them. Pretty much the integers values, long values, and so on. The instances of all wrapper classes are immutable. So that means you, after once created, you cannot modify it. Their internal values cannot be changed once the objects are created. So this is a wrapper class for integers. It's part of the java.lang package. And this is a wrapper class for double. So we can see that we have the attributes like max values and min values. And we have constructors. Constructor can take the int value or string. We have byte values, short value, int value, long values, float value. So that means you can convert the values to any type through this methods. Boolean. You can do compare to see which one is greater. Compare to returns negative when it's smaller. Equals zeros when it equals. Return 0 when it equals. And return positive when it's greater. And we have two strings that return the format of string. You can change integer to string through the integers. Pretty much you can just do .toString here or value of and pass string and you get the integer back. And we normally use this already when we read in from text. You have to convert it to integers. You call integer.parseInt. It's pretty much just a wrapper class that you already use. Now, double pretty much the same, similar manner here. So most likely we have the constructors, we have the constants, max value and min value, and we have the conversion methods to change the types. So let's look at this here. This is the method that you pass in the values to instantiate the constructors to get the value, either integer or double. You can use int or string or double or string. So each numerical wrapper class has the constants, max values, min values. So max value represent the maximum value of the corresponding primitive data type. For each type, byte, integer, short, long. Min value is also represent the min value of byte, short, int, long. For float and double, you have min value represent the minimum positive float. Like we know that when we define a primitive type, we know there's a min value for it based on the size of the bit, right? Like integer has 32 bits. So the max value is going to be 2 to the power of 32, but you have to divide by 2. So let me show you exactly what I mean here to get min and max. Like if you look at Java primitive data type, so if you define int, for example, it's 32 bits. Right, the max value that it can represent is 2 to the 31 minus 1. And the min value is 2 to the 32 minus 1. That's what it's referring to. Like for example, if I define bytes 8-bit, the max value is going to be 127 and min value is going to be minus 128. How do we get that number? So 2 to the power of bit is 256. And we have to divide in half. Half for positive is between 0 and 127. And another half for the negative, minus 122 minus 1. So this is the min and this is the max values. So that means when you use the wrapper class, again, right? So all the wrapper classes, they all implement the from implements of the abstract method from the number class. Number class is the parent class of our wrapper class. And we will talk about inheritance and you understand this concept more. Now, statics value of methods. We talk about statics, right? So the numeric wrapper classes have a useful class method, which is the value of strings. So if you put a string, you can get the value of, if you say integer.value of string, then you get the integers values back, like that example. Double value of 12.4. So technically you convert string to double or string to integer that way with those statements. And these are the static methods. And we talk about that. That's why you don't need to instantiate, you just invoke through the class name. And static method, they are not tied to the instance. So the method for parsing strings into numbers, you have used the parseInt method before, if you remember. When we read string, we can just parse it into numbers. Like integer.parseInt. We didn't have example here. Let me show you then. Like we were using when you do like GUI, you just say integer.parseInt and you pass in the string values, right, of the integers. Like you can do like text, your text field dot get text, right? If you remember that, and then you just get the integer values, then you can make that to calculate like values equals. So that's a statement. And it happens the same when you do like another type like double float values value of, instead of integers we just do like double.parse double, and we can just get the text field values to convert back into the actual double value like that. So that's a parse. Each numeric wrapper class has two overloaded parsing methods to parse a numeric string into an appropriate numeric values. So let's talk about overloaded. Let's scroll back to that. So what's overloaded? Here's the overloaded. Like I show you, I call that methods here, parseInt, pass in the string. Overloaded means the method that has the same name, different signature. Same name, different signatures. So what is the second one then? The second one pretty much just passing the number based system. We have base 10, base 8 binaries. So like for example, if I want you to write a program to convert number from base 10 to base 2, there you go. So use parseInt. It's going to base convert that, and then you just say if radix in is 2 is base 2. So that's how we use the overloaded constructor here. We'll see an example. Parse in radix example. Like this. If I want to have hexadecimals, so I pass in integer, right? So we want to use parse right here. Dot parseInt, and the number 11 can convert into base 16, which is hexadecimal format. So we write a code and show you. So we're going to show this in the code here. 11 is going to get converted into base 16. This 11 is in binary.